Hello everyone! In today's video, we'll be learning about sample spaces and events in probability. So let's just dive right in. Probability is built upon set theory. Actually, the two are very intertwined, and set theory, I would say, provides the mathematical foundation that allows us to very systematically understand uncertainty, random events, and random phenomena. So first, let's talk about the sample space. So we define a sample space using the capital letter S, and it just is defined as nothing more than the set of all possible outcomes of an experiment. So let's take this first example where we're rolling a six-sided dice. If we're rolling a six-sided dice, the sample space S is just all the possible outcomes that can happen when we're rolling that six-sided dice. So it can land on 1, 2, 3, 4, 5, or 6. Let's also take a second example where we're flipping a fair coin. If we're flipping a coin, the coin can either land on heads or tails. So we define that as our sample space. An event, which we call capital A here, but we really can define it as capital A, capital B, C, D, etc., etc. An event is just a subset of the sample space. So let's go back to this example where we're rolling a six-sided dice. We can define event A as rolling an even number. So if we're rolling an even number, then the event A is either 2, 4, or 6. So rolling a 2, a 4, or a 6. In the second example, where we're flipping a fair coin, we can define an event as landing on heads. So then our event A is just H, which is landing on heads. All of these basic definitions and terms about sample spaces and events might seem very basic, but understanding probability in terms of sets will allow us to work better and better understand these different events. So let's move on to set operations, which are unions, intersections, or complements. These unions, intersections, and complements, they allow us to manipulate and analyze events in terms of set theory. So let's start off with the union of two events. So the union of two events, which is denoted as A union B, is representing the event that either A happens, B happens, or both happen. So we can think of this in terms of a Venn diagram. So let me draw this out for you. So if A is happening, then all these events in A are occurring. If B happens, then we get this shaded region here. And if both happen, then that's this region here. But the union is basically the entirety of all of these events here. So going back to the dice example, let's say we roll a six-sided dice. So our sample space, hold on, let me write example. So we're rolling a six-sided dice. The sample space is 1, landing on 1, landing on 2, 3, 4, 5, or 6. The event A could be rolling an even number. So if we're rolling an even number, that could be 2, 4, or 6. And we can also define an event B where we're rolling a number greater than 4. So if we're rolling a number greater than 4, that's either 5 or 6. So the union A union B is A 2, 4, 6, B, which is 5 and 6, but we already have 6 written there, or both, which is 6. So then A union B is 2, 4, 5, or 6. Next, we have the intersection. So the intersection of two events, which is A intersect B. And it's the event that represents where A and B are happening at the same time. So both of them have to happen at the same time. And if we look at this on our Venn diagram, that would be this region here. Now going back to our dice example, A intersect B is the event that A and B happen at the same time, which just happens to be 6. Lastly, we have what is called the complement. So A complement, that's how you would denote it. And the complement of an event are just all the events that are not in A. So looking at the Venn diagram, everything that does not happen in A is everything outside of A. And in our dice example, the complement, A complement, is rolling an odd number. So then A complement is just equal to 1, 3, or 5. So now that we know about unions, intersections, and complements, we can talk a little bit about De Morgan's laws. These laws allow us to relate unions, intersections, and complements. So we can basically rewrite different expressions of events using these two different theorems. So the first theorem says the complement of two events, of the union of two events, is equal to the intersection of their individual complements. So I think this is a lot easier to visualize on a Venn diagram. So let's look first at what is the union of A and B. The union of A and B is everything that happens in A or everything that happens in B or both. The complement of A union B then, is everything that is not in that union. So everything that is not in that union is this yellow region here. So let me just color that in. Now let's look at the right side of the equation. The complement of A is everything that is not in A. So that red region there. The complement of B complement, is everything that is not in B. The intersection of those two events is everything outside both A and B. So everything outside both A and B, which happens to be this yellow region here. The second of De Morgan's laws states that the complement of an intersection is equal to the individual union of individual complements. So as before, let's look at this on the Venn diagram. So the intersection of A intersect B is where both A and B happen. But the complement of that intersection, A and B, is everything that's not in that red region there. So this yellow part here. looking at the right side of the equation, we're looking at a complement. That's everything that's not in A. B complement, the complement of B, is everything that's not in B. And the union B of A and B complement is everything that's not in A or everything that's not in B or both. So everything that's not in A or everything that's not in B or both. So these two Venn diagrams are matching. Just to recap really quickly, in this video we covered set operations, unions, intersections, and complements, which are basically the fundamental building blocks of probability. Unions combine events, intersections find common outcomes, and complements deal with everything that's outside an event. And we also looked at De Morgan's laws, which help us manipulate these expressions and better understand how events interact. But if you found this video helpful, make sure to like, subscribe, and comment below with your questions. But thank you so much for watching, and I'll see you in the next video.